Okay, due to the typhoon last week, so we skipped the rectifier circuits about the diode uh, last week. So we're gonna keep going to this uh, next chapter. Okay. Okay. So the next chapter we're gonna talk about the BJT, which is called the bipolar junction transistor, and we're gonna know about the working theory about this transistor, and know about the difference between the NPN type and PNP type BJT. We're gonna use the meter to judge the uh, transistors, can it work or not, and we also try to know about the current relationship and draw the IV curve about this electron device. Let's talk about the basic knowledge about this transistor first. The PNP type transistor, which is consists of three layer, and there are two P-type semiconductor and one N-type semiconductor, have been put it between these two P-type materials. And the middle one, which is called the base, it has the different doping characteristic rather than other two materials. And on the left-hand side, we can see that the emitter, which is a P-type material, and the right-hand side, a collector. So there are two PN junction in this BJT electron device. And we can see that the NPN type is totally different from the PNP type, which is combined with two N-type material and one P-type material to be the base of this transistor. So the working condition about this transistor, as we can see on the top left side figure, we add a forward bias between the emitter and the base. This PN junction has a forward bias VBE in this biasing condition, and the current flow is there is an IE flow into the emitter and an IB flow outside the base. As we can see on the right-hand side, there is a reverse bias we added on the left PN junction, and the IC is flow outside the collector, and IB is flow in. But when we simultaneously connecting these two biasing onto the BJT, we can see that the uh, holes in the emitter has been flowed through the base, and finally it reached the collector. And the a part of these holes has been uh, recombined with the majority carriers in the base. So it will reduce its amount. So the total condition about this uh, active mode BJT, we can see that an IE has been flow into the emitter, and IB and IC has flow outside these two uh, materials. And we can see that the BJT, uh, we can assume it a big node on the circuit. So the relationship between these three currents, the IE equals IB plus IC. While the NPN type BJT has similar but a little bit different from the PNP type, we can see that the main character we focus is changed from the hole into the electron, and the current flow direction is totally different. The IB and IC is flowing into the device, while the IE is flow outside the device. And the biasing condition, we also that the emitter and the base junction uh, give it a forward bias, and on the other hand, the collector and the base is a reverse bias. Here are the symbols about the BJT we use to describe on the circuits. As we can see that the bottom of the figure, there are three different branches that the device has been connecting to, and the middle one is the base of uh, the device. And we can see there is an a symbol arrow that connected to the emitter of the NPN BJT, and the other one is called the collector. And the PNP type, we can see the direction of this arrow is different from the NPN type, and the direction of the arrow, which indicates the current flow direction, and we can see that the IE in this PNP type is flowing into the device, while the IB and IC is flowing outside. And here are the direction of these different branches about the current flow. The NPN type and PNP type has different direction. And here are the output characteristic about the IB to VB curve. It's very similar to the diode we learned on the previous chapter. There's a voltage, we call it the cutting voltage in the diode chapter, that the IB has a large increment after we added VB larger than 0.5 volts. And on the right hand side, the IC and to the VCE curve, we can see that the current is increase very sharply, but it has saturated to a very stable value. But basically, that if we change the different IB, is the curve, the amplitude of the curve is increased. So today we're gonna use the meter to judge about the BJT, the type of it, that is PNP type of the NPN type, and we have to know that which branch is the emitter or the base or the collector. We're gonna learn about how to judge this electron device, and that starts today's experiment.